Hi, my name is Professor Ian Griffiths and I'm a tutorial fellow at Mansfield College. And today we're going to do a demo interview to see what it's like to have an interview for undergraduate mathematics. And I'm going to interview Robin here. Robin, if you want to introduce yourself.
Hiya, I'm Robin. I'm just finishing my second year doing maths at Mansfield.
And so this interview will be as close as it will be to an actual interview. And now, before you come along for this interview, we will have looked at your UCAS forms to select you, and you will have done a math exam, which we will have the scores of as well. So all this will come into assessment of you. And then the interview is the final stage of the process. And as you'll see in what we do now, the interview will consist of some introductory questions, and then we will do some technical questions and then talk more broadly at the end. So now let's do the interview then, as it would happen in general. And this will give you an idea of how they work. Okay. Hi, Robin.
Yeah.
Nice to meet you. So
Yeah,
we have your UCAS forms here and we've taken a look. So if you'd like to start off by just telling us a little bit about the mathematics that you've been enjoying for your A-levels.
So I'd say one of my favourite things that we've been doing is probably the proof by induction stuff, because I really like how you can kind of break down a much bigger thing into like 3 steps and then just kind of have them work together to give you a kind of result that's a lot more complicated than the kind of sum of the parts that you've done, if you like.
Yeah, that's good. And you'll certainly get to learn a lot more proofs of this nature when you come and do your undergraduate here. Okay, that's great. So what we're going to do now is we're going to ask you some technical questions, and while I'm doing that, I'll make some notes, but you shouldn't worry about that. Those notes are just for my benefit. And because we're doing it online today, I'm going to share a screen which will allow us to use a whiteboard together. Ordinarily, we would do this either on pen and paper or on a whiteboard.
Sure.
Okay. So, and at the end of the interview, there'll be a chance for you to ask any questions if you would like to.
Okay.
So let's get started with this. I'm going to draw a little picture now, and I'll try and draw it in the top corner here. So here we have a wall, vertical wall here, and a floor here. And then what we've got here is a ladder, which has a total length of L, which I'm going to draw here. And what I'm interested in here is, let's suppose that the ladder falls from the wall because it's vertical, it's just precariously balanced, and it's just going to topple away from the wall now. And I'm interested in, if I draw a little cross in the midpoint of this ladder here, suppose we've marked the middle rung, for instance, what is the shape that this cross forms as the ladder falls? Is that clear?
Yep. Okay. So I guess because the bottom of the ladder's going to be staying where it is in the bottom corner, right? So that would mean that the midpoint's going to have to stay the same distance away. So I guess you'd end up with a quarter circle, I think.
Yeah, a quarter circle, exactly. And what's the radius of that quarter circle?
So the ladder's length L, so I guess half L.
Yeah, exactly. Do you want to draw that on, just so that you know the shape?
I'll just check. Sorry. So it'd be something like that.
Yeah, perfect. Yes. And then do you want to just mark on the point at which it hits the horizontal axis? So maybe label these horizontal and vertical walls that I've drawn. Maybe label those as axes now, X and Y.
Sure.
and then put a coordinate on. Yeah, that's it. Yeah, exactly. Okay, right. So that's great. Now I'm going to look at a different situation and say, rather than the ladder just toppling, let's suppose that the bottom of this ladder is slippy. So now it just slips down the wall. So you could imagine that there's a person standing on this ladder and it just slips away. Okay. So now I'm still interested in this cross, which is the middle rung. But as this ladder slips away, what is the shape that is now formed? Is that clear what I'm asking?
Yeah, I think so.
Yeah. So tell me what you're thinking.
I'm just kind of trying to imagine what it would look like. Maybe like a straight line this time.
Okay, that's good. Yes, and why do you think that? Where did that come from?
Well, it's got to end. It's going to end up in kind of the same kind of place as it did in the other example.
That's a really good point. Yes, so you know where it's going to end up, and you said same. You said same kind of place. Does that mean it's close or?
Well, so it was doing that, but now it's doing that. So I guess it's the same place, but the ladder's kind of the other way around.
Yeah.
I think.
So that's really good. Do you want to put a cross on, maybe in a different color, to say that you know where it's going to end up?
Sure. I'll go blue this time. Okay. So it's still going to be there.
That's really good. And you also know the start point. Maybe draw the start point.
Yeah.
Well. Okay, that's great. So you've made some, and now you're hypothesizing that it might be a straight line that goes through that.
Yeah.
Can we actually do this mathematically to work out? So let's consider this ladder at some intermediate point, and maybe draw the ladder in this intermediate.
So it'll look something like that, I guess.
Yes. Yeah. Very good. Okay. And and that's good. You've drawn the midpoint as well now. So can you work out for that position where the midpoint is? So you've done a specific ladder position, and I want to know where the midpoint is.
So the ladder's still length L. So I guess I can use Pythagoras.
Okay.
So I guess, so if we say that its ends are x and y, so we know that x squared plus y squared equals L squared. Yeah. And then I think that the midpoint of the ladder has to be at the halfway. It's at half x. Yeah, it's kind of the x coordinates half x and the y coordinates half y.
Are you sure?
Not anymore.
I'm just making sure that you're convinced.
Am I sure? Yes, I think I am.
Yeah, good.
Yeah.
Yes, I'm glad you're convinced. Okay, so what does that mean then?
So we know that I'm not quite sure. Sorry.
Okay, no, that's good. That's good. Yes, so you're doing really well. So you made a good statement there about the fact that the ladder position here is exactly halfway in the horizontal direction.
Yeah.
And exactly halfway up in the vertical direction.
Mm-hmm.
So what does that mean in terms of, so you've said that the position of the far right of the ladder is
Yeah.
X,
Yep.
and the position of the top of the ladder is Y.
Yeah.
So if you're parameterizing in that way with the X and the Y, what does that mean about the position of your center point here? Where does that lie?
So it's just it's going to have coordinate like half X, half Y.
Okay. Yeah, that's good. And what else do you know about this ladder shape that's formed in your XY space?
Well, it's always going to be a triangle.
Yes. Yeah.
This is the way it's
Exactly.
falling
Yeah.
down.
It's a triangle.
So
So the blue line here.
yeah.
Could you write down an equation for what this line looks like?
Yeah. So it's going to be Y equals minus. Oh, this is going to get messy because I've called my X and my Y X and Y.
Yeah, exactly.
Yeah.
So that's a really good point. So maybe you want to think about parameterizing it in some way. So let's suppose that in the way that you've drawn your ladder at the moment, let's call the, I don't know, the horizontal position A, for instance. So you're parameterizing at each
Yeah.
point A. Yes.
Yeah.
So is that going to help you now to write down the equation of the ladder? So the equation of all points X, Y on this ladder, if the bottom right point is at A.
Yeah. So Y. So it's Y is going to be 0 when X is. Oh, I'm confusing myself now. Sorry. Y is going to be. Yeah, Y is going to be 0 when X is A. And
So what's the general form of this equation going to look like?
it's going to be a Y equals mx plus c thing, isn't it?
Yes, exactly. So you just need to work out, if I give you A, what does the M and the C look like?
Yeah. So the C is going to be my point where it meets the y-axis.
Mhm.
Shall I call that B or something?
Yeah.
B, and then so that's going to be minus B over A.
Yeah. And now, do you have any relationship between B and A here?
That's my thing at the top, isn't it? My x squared plus y squared is L squared.
Yes, exactly. Good. Okay. So can that allow you to write your equation for your ladder position in terms of just one parameter, either B or A?
Yeah, I think so. So I can use this thing at the top.
Yeah.
And I'll get rid of my B or Y. So y squared equals L squared minus X squared. So I'm just trying to rearrange my Pythagoras thing into a y equals something, and then I can plug that into my equation for the line.
Yes, good.
So y equals plus 4 minus square root L squared minus X squared. And then the ladder's not going to fall through the floor, so I don't need to worry about the plus or minus.
Yes.
And this y is secretly b, isn't it? I think.
Yeah. Well, that's equal to b, yeah. Okay, so that's good. So now what you want to do is substitute your b into your equation for the straight line that you've written down there. Before you do that, are you sure that's right? So you've got b equals square root of L squared minus X squared.
My b's should be going with a's, not x's, shouldn't they? So maybe that ought to be
yes, because b is just a number.
Yeah, so that's a squared. Okay.
So now if you
oops.
Okay, that's great. So that tells you the equation of your ladder, your blue ladder, at any given point that's parameterized by the horizontal position A. So if I give you an A and I give you a ladder length L, then that gives me the equation of the line. Okay, so now remember we're interested in the position of the midpoint. So what value of X is at the midpoint?
So that was, I'm not actually looking for, sorry, so that's,
and you talked about this a bit earlier.
X is half A, isn't it?
Yeah, exactly. You said earlier that it's a half A and a half.
Yeah, so I want y when X is half A. Yeah.
Yes, yeah, okay.
Y equals minus root L squared minus A squared all over A over 2 squared L squared minus A squared.
Okay, good. Right.
This looks quite messy with the square roots. Maybe I want to square it up and see whether that.
So before, okay, yeah. So do you want to try and simplify the right-hand side a little bit first of all?
Yeah, that might help. So I can. Oh yeah, I can do lots of things, can't I?
Yes. Yeah.
That times 1, and then my a's cancel, don't they?
Yeah.
Minus half.
Good.
And that's just a half, isn't it? Well, yeah, 1 minus a half.
Yeah.
Okay.
Yeah. So that's a lot simpler now.
Yeah. So now I can just try and I'll square both sides and try and get rid of the square root and see what that looks like.
Good.
I'm just going to move over to the left, so I've got a bit of space.
Yes.
So y squared. So y squared is just a half square root L squared minus A squared, isn't it? No, sorry. I was getting rid of that. A half.
Yeah, very good.
L squared minus A squared.
Now have a look and see because you've squared the one side and then you kind of made a bit of a mess of the right hand side. So just have a rethink. Maybe take a step back and just do it again.
Y squared is L squared minus A squared times. Oh, that's a half squared, so that's quarter, isn't it?
Yeah, very good.
There we go.
Right.
That,
Now, if we want to have the equation for the position of this center point, really that's going to be some equation with y's and x's in. Okay.
yeah,
Now, at the moment, you've got an equation in terms of y's and a's. So
yeah.
can you remember what the relationship between a is and x?
A was just my X, wasn't it?
So a is the position of the end of the ladder.
Yeah.
X, if we're interested in the x,
Oh, so
the
it's A
position of
over
the,
2. So
yes, exactly. So
A's
if x is our
2x.
position of that, yeah.
So that's 4x, I guess.
Be careful for x.
Squared.
Yeah, very good.
Okay, and then y squared plus 4x squared.
So hang on a minute. So check your algebra on the line above. So you've got a quarter, L squared, and
Over
then you've
4.
got, yes.
So I can just get rid of that.
Yep.
Y squared plus x squared equals quarter. Okay, so that's a circle, isn't it?
It is a circle, yes. What radius?
Half L.
Yes, okay. And so if you were to draw that on your sketch that we have above, maybe in a different color, what would that look like?
That's just the same as the first one, isn't it?
Yes, exactly.
That's neat.
Yeah, so exactly.
Oh.
So what you've learned here is that if the ladder topples and you're interested in the middle rung position, or if the ladder slides down the wall, then actually those two, the shape that is mapped out is exactly the same, which as you saw at the beginning, you might not guess. You kind of guessed that it would be a straight line if the ladder slid down. So it's not obvious that it forms an arc of a circle. So that's kind of an interesting observation.
That's really cool.
Yeah, okay, good.
Nice.
Well, that's the end of the technical question. Do you have any questions for us? You don't have to have any. This isn't part of the interview, but if you do.
So I know that tutorials are kind of a big thing at Oxford. If you're Mansfield's maths tutor, does that mean that if I was at Mansfield, all my tutorials would be with you, or?
That's a good question. So we have several tutors at Mansfield, and all the other colleges also have several tutors. I would do most of the applied tutorials for you in the first and the second years, and then you would have other tutors that would do the pure aspects and maybe any statistics if you were to do that as well. And then when you get into your third and fourth years, the tutors for Mansfield will be less involved with you, and you would have what are called intercollegiate classes, and that's where you mix with all of the other colleges, and you will have sessions with about 10 or so other students, and there will be a tutor that covers all the questions there.
Okay.
Is that good?
Yeah, thanks.
Okay, good. Well, thank you for coming along, and good luck for your other interviews, and maybe we'll see you here soon.
Thank you. Nice meeting
you. Good. Great. Nice to meet you too. Bye.
Bye.
Okay, good. So that was a mock interview, effectively. Let's just talk a little bit about how the interview went and some of the pointers,
Sure.
at least from my perspective. So we started off the interview, and I talked a little bit about what Robin was interested in at school at the moment, and this is really just to relax Robin and make him feel comfortable and ready to tackle the interview. And then we launched into the technical part of the interview, and this is the main body of the interview, really. This is where we're interested in assessing the potential of the candidate. So you'll see that Robin made various mistakes along the way, and that's fine. And there were quite a lot of pauses as well, and that's deliberate. So if you're a candidate coming and you're sitting there and you might think this is terrible because the examiner or the interviewer is just staring at me, that's fine. That's to give you a chance to think. And the other good thing that Robin did was to talk about what he was what his thoughts were. So some of them weren't right, but at least it gave us a discussion point. And that's what this is all about. This isn't so much about Robin just zooming through this question with no problems, because if he does that, then we haven't really got a good assessment other than he was good at this question. What it's about is how Robin responds to my prompts. And you will see that various points along the way, I would prompt him to think about something in one way or another. Or perhaps he'd gone down a blind alley or done something slightly wrong that would have led to a mistake later on. So my job is to correct as little as possible, but also ensure that there's a dialogue going on as well. So those are some of the things that we're looking for in an interview. What you'll notice also is that Robin stayed calm. There were points at which he actually really didn't know what to do, but that's okay. That's to be expected. And what he didn't do was just panic and say, I don't know what I'm doing here. This is a disaster. He just sat quietly and thought and listened to the comments that I was making. So those are the sorts of things that we are looking for in an interview. Robin, is there anything that you have to say from your side on this?
Yeah, I was actively trying to kind of think aloud a bit, which feels a bit unnatural in maths, because normally you just sit in silence and try and do the question and either do it or maybe give up. But I think because the interviewer can't see what you're thinking, it's important to sort of say, I'm doing this because I want to get to this and that kind of thing. And then that makes it a lot easier for them to give you help if you're doing something wrong as well. Because if you're vocalizing it, they can go, oh, he's trying to do this, this isn't right, rather than just looking at what you're writing and going, I've got no idea what's going on here.
Yes, yeah, that's really good. If you're just writing things and not explaining, you could be doing something correct. You could be coming at it from a different angle, but we don't know. And the whole point of this interview is to establish a dialogue, and that's what tutorials are like here in Oxford as well. It's about chatting about what you've done and talking through the solution and whether you could have approached it from a different angle and things like that. So hopefully that's given you an idea of what an interview for mathematics at Oxford looks like, and I wish you all the best for your applications.